All of you welcome in your next period, Maths paper 5 numerical analysis. We have seen the bisection method. In that method we divide the interval by the midpoint formula. Now we see the next method, Newton's method. We start with any initial point x0. The next iterate is obtained by considering the tangent line touches to the graph of the function f of x, y equal to f of x at the point x0, f of x0. You can see in the figure, this is the curve y equal to f of x, this is the tangent line, and this is the point x0, f of x0. After finding this iterate x1, we find the next iterate x2 by considering tangent at x1, f of x1. Here is x0, f of x0. In the next point x1, f of x1. Instead of taking the point x0, f of x0, we take this point x1, f of x1, and we continue and so on. Since x1 is given by the point of intersection of the tangent line with the x-axis, we must have. What is x1? x1 is given by the point of intersection of the tangent line with x-axis as in the figure. Therefore, we must have f dash of x0, that is derivative at the point x0 is given by difference of these points. We have 0 minus f of x0 divided by x1 minus x0. Therefore, we have x1 minus x0 cross multiply here x1 minus x0 into f dash of x0. Therefore, we have x1 minus x0 equal to minus f dash of x0 divided by this f dash of x0. Therefore, we find value of x1 taking x0 on the right hand side. x1 equal to x0 minus f of x0 divided by f dash of x0, which is nothing but the first iterate. x1 is given by this formula, equation number 1. The initial case, if the initial case is such that f dash of x0 equal to 0, then if here f dash of x0 equal to 0, then we cannot obtain the iterates of higher order with the help of f of x0. Then here we choose another cases. We take the next iteration. The next iteration x2 is given by, here is x1, here is x2. Now in place of x0 we have x1. Therefore the next iteration x2 equal to x1 minus f of x1 divided by f dash of x1. Similarly, we continue the process, we obtain x3 equal to x2 minus f of x2 divided by f dash of x2, and so on. Therefore in general we have the recurrence relation or recurrence formula to find any iterate. We have xn plus 1 equal to xn minus f of xn divided by f dash of xn. If there is x2, then there is 1 less, therefore it is xn. If here 1, then here 2, that is xn, here xn plus 1. And here f of x1, f dash of x1, therefore f of x1, f of xn divided by f dash of xn. So generally this result, if there is x1, 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 here is x2. Therefore in the formula xn, 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 here is xn plus 1. If I recall the second method, then we have xn plus 1 equal to xn minus f of xn into xn minus f of xn divided by f of xn minus f of xn plus 1. But by mean value theorem, we have dash of xi equal to f of xn minus f of xn plus 1 divided by xn minus xn plus 1. Therefore value of this we are taking the reciprocal of this, we get this bracket. Therefore it is 1 upon f dash of xi. Therefore xn plus 1 equal to xn minus f of xn divided by f dash of xi. For this xi belongs to the closed interval xn plus 1 xn minus 1 xn. This is about the Newton's method. We will see in particular examples on this method to find the root of the equation. Therefore, this is the general formula: xn plus 1 equal to xn minus f of xn divided by f dash of xn. This we consider the formula for solving the examples. Example: by using the Newton's method, find the root of the equation x cube minus 3x minus 5. Solution. Now we will use the Newton's method to find the solution. Now here we consider f of x equal to let f of x equal to x cube minus 3x minus 5. Now here we observe that the root lies clearly the root lies between x equal to 2 and 3. Here we observe that the root of this equation lies between 2 and 3. Because f of 2 equal to 2 cube minus 3 into 2 minus 5 equal to 8 minus 6 minus 5. Therefore f of 2 equal to get minus 3 and which is negative. And f of 3 equal to 3 cube minus 3 into 3 minus 5. 27 minus 9 minus 5. This will get as 30. which is positive. This is negative, this is positive, therefore we say that the root lies between 2 and 3. Now from equation 1 we find the derivative. From equation 1, f dash of x equal to 3x square minus 3. By Newton's recurrence formula, we have xn plus 1 equal to xn minus f of xn divided by f dash of xn. Therefore, xn plus 1 equal to f of xn. This is f of x is given by this. We find f of xn by putting x equal to xn in this equation. Therefore, f of xn we have xn cube minus 3xn minus 5 divided by f dash of xn. The f dash of x is given by this 3x square minus 3. Therefore, f dash of xn, put here x equal to xn. Therefore, 3xn square minus 3. Here we consider the initial theta rate at x0 equal to 3. Choose x0 equal to 3. So, equation 3 implies x0 equal to 3, we find, if we put here n equal to x0, we have x1, we get the first theta rate x1. Therefore, x0 equal to 3, we put here n equal to x0. Therefore, x1 equal to here x0 minus x0 cube minus 3 x0 minus 5 divided by 3 x0 square minus 3. Therefore, put the value x0 equal to 3. 3 minus 3 cube minus 3 into 3 minus 5 divided by 3 into 3 square minus 3. Therefore, 3 minus 3 cube 27 minus 9 minus 5 divided by 9 into 3, 27 minus 3. Therefore, 3 minus 3 minus 13 divided by 24. If you take the LCM 24, then you have 72 minus 13 divided by 24, which is nothing but 59 by 24, and which is equal to 2.46. Therefore, x1 equal to 2.46. Then to find next. Now this we find x1 by putting here n equal to 0. We find x2 by the formula 3. Therefore, to find x2 we put here n equal to 1. If you put n equal to 1, we get x in x of 1 plus 1 to x2. Here x1 minus x1 cube minus 3x1 minus 5 divided by 3x1 square minus 3. Then put n equal to to get next value x2. Therefore x2 equal to x1 minus x1 cube minus 3x1 minus 5 divided by 3 x1 square minus 3. Now put del of x1 equal to 2.46 minus 2.46 cube minus 3 into 2.46 minus 5 divided by 2.46 square minus 3. Therefore 2.46 minus cube of this 2.46 is 14.8869 minus 7.38 multiply of this minus 5 divided by square of this, you will get 13.15 48. Then multiplied by 3 is here. Minus 3. Then solve this again. Equal to 2.46 minus 2.5069 divided by 15.15 volt. That is 2.46 minus 0.1654. Therefore, the x2 will get 2.295. Similar to find the next value. Now from the general formula, from the equation 3, 2.x, we put n equal to 2. If we put here n equal to 2, we have 2 plus 1, 3. Here we find x1, x2, then x3. To get x3, we put here n equal to 2. Therefore, x3 equal to x2 minus x2 cube minus 3 into x2 minus 5 divided by 3 x2 square minus 3. Again by 3 we obtain x3 equal to x2 minus x2 cube minus 3 x2 minus 5 divided by 3x2 square minus 3. The total value of x2, which is nothing but 2.295, and simplify, so we get xm equal to 2.279. Similarly, you obtain x4. x4 will get 2.279. Same value. So this will get same value x3 and x4. Therefore, the procedure is complete and we obtain the root of the equation by Newton's method.